Hi, so the most complex thing that I make in my game is making the character to draw on the whiteboard every time he moves and when he's in black. So I will show how it looks like. So in order to make that, I'll create like an RT whiteboard. This is a set of pixel we can override onto. So you can see here we override that with the white color. The reason the color is different is because what we see outside is not in here. So what we see outside is actually inside of material whiteboard. So that's how we process the RT whiteboard. So in here, we get the color we want the character to draw, and this is the color of the background outside. So what I do is I multiply the RT whiteboard with the parameter. So what it does is it getting the white pixel from the RT whiteboard, convert them into black, and the remaining black pixel will blur with the white. So you can see that. So we will have the black inside the white. So what it's look like is how it looks like at the end. Next is how I apply it. So I apply it into the BP whiteboard. So BP whiteboard is actually the background of the game. So you can see here, it's actually the outside of the game. So how I make it is firstly, when it start, I need to create a marker inside to draw onto the background in the runtime. The reason why it's dynamic material instant is because the marker needs to move around in the runtime to draw onto the whiteboard. And then I will set that marker, so I will save that marker here so I can use it, and then I will reset the RT whiteboard every time I play the game with a black color. And it will have a function to draw on the whiteboard, to draw it itself. So when it gets a location, it will send that location into the whiteboard marker. The whiteboard marker is actually a material, and then I'm using draw material to render target to use the whiteboard marker override the RT whiteboard. RT whiteboard. So how I make the whiteboard marker is in here. So firstly, I'll get a location. The location will X and Y will be stored inside of the RNG. So mask is actually getting out the RNG here. And then I'll subtract by the coordinate just to fit it. And then I'll convert it into a vector. And then I'll subtract them by 1 again so that it can fit into the camera of the character. And then I will get the draw size. So the reason why the draw size the draw size is actually the size of the character. The reason why it's so small is because I'm using subtract and divide here. So it's like when you scale the background up like 100 times, you need to scale the size of the character down 100 times so you can actually see that we're drawing the right thing. So after clamping and dividing, we'll have the location and the size of a character, and we will make a material to override the RT whiteboard. Lastly, how we find the location is every second, if the character is black, then we will detect where the character hit the background. So light trace by channel actually is like, so we have a start and we have the end. So it will detect anything. So it will make a line if anything is between them. Firstly, it will detect that thing, return the location of that one. So in here, we get a location of a character. We'll measure them down we'll measure them how minus 5 times 5,000 unit. In the y-axis, it means like we'll minus every. Is there anything hit the character behind the character? So what we do is we measure the character location on the background. So when it hits, so where the character hits the background, so we get that one pass into the whiteboard, and also it would detect the location where it hits. So final collision UV actually find where it hits, and it will return into the whiteboard. So it will move into here, get the location, send it to a marker to draw and override the RT whiteboard. So that's how it looks like. So I also do some very interesting thing as well. Firstly, is about the character state. So in here you can see the state. The character will have many state: jump, duck, duck left, duck right, and the move will be like anything that's not the state. So when it's jump, it will change the state. It's jumping. When it's land, it will change the state back to idle. And for every state, there will be an animation for it. So you can see here, there's the idle, the move, the jump, the duck. So also how I also make a very interesting interaction, like the player can move while crouching. So to how I make it is when the player is crouching, when they press D or right or left or A, so they are moving, they will set the condition to true and they will set the state into duck right or duck right will crouch the character. Because crouching here is different from 3D character, so it actually reducing the hitbox of the character but in the center of the image. So it result in the character will be underground, so we need to move the image up by like half of it. So it's 48 is the height of the half of the height of the character, so we move it up so the player can see that the character is not under the ground. So when the player releases the C, it will set back to IO, uncrouch, and set the image back. So you can see. So that's the movement of the character, how I make it, and it's actually reducing the hitbox of the character as well. I also make the few levels like level 2 and level 3, and also make a main menu, but they are not so interesting, so I'm not gonna talk about it in here. Thank you.